Hello. Okay, are you hearing me well? Is the sound good? Okay, so yes, it seems that everything is okay. So let me just upload maps in order to see you where I live and where is the University of Moncton. So I'm very glad to be your professor for this week, and my name is Sid Ahmed Selwani. I am from Moncton University, Canada. So let me just upload a file showing you the maps. So please, if you have any comment or any inquiry or something like that, so please say it by text, or you can also use your microphone. I think that it's possible for are you showing me in the camera? I don't know, but I will okay, so okay, I think now you can see me, right? Okay, please just confirm that you are not yet. Okay, so camera news. Okay, microphone is good, speakers are good, the camera, I'm going to go. So, okay, so just please confirm that, okay, good, Hassan, okay. So just before starting our first course, let me show you where is New Brunswick. New Brunswick is in the Atlantic side of Canada. So you can see Canada here. This is a small province here, okay, in green. Okay, this is maybe I can zoom it to you. Are you seeing the map? Okay, so here is New Brunswick. So you have Quebec, Ontario, Manitoba, Saskatchewan, Alberta, British Columbia. So this is the Pacific Ocean and Atlantic Ocean. We are here. So I am broadcasting from here. Okay, yes, good idea. Is it a good? Okay, this is the New Brunswick. Okay, in the east of Canada. Okay, and New Brunswick, if you see New Brunswick, this is the map of New Brunswick. It is like it looks like France, no? Somehow. So maybe if you have something like here. Okay, so where I'm, the university has 3 campuses in Moncton here, and we have a campus here near Bathurst, and a campus here in Edmonton. So we are in the northeastern of New Brunswick. And you have Quebec here, and here you have US. You have the main state. Okay. And here you have another province, which is Nova Scotia. The capital is Halifax. And here you have the Prince Edward Island, which is another province. And far from here, you have Terra Nova, which is another province. So here you have Nova Scotia, Newfoundland, and New Brunswick province. Is it okay for you? So the sound is good. Confirm to me that the sound is good. Okay, good. So now you know, and there is 5 hours. 5 hours delay. So now it is 1 p.m., 1:30 p.m. It is 8:30 a.m. in New Brunswick. So let's start with the summary of the course and what are the duties for you. So we have 4 days. The first day we will speak about the RFID technology, the basics and the physics that are very important for your progress. Then we will finish the course with some exercises in order to see if you understood the concepts that we have seen before here in the module 1. So I also give you in the, I think that the content is available in the library, right? Could you confirm, please? So you have the module 1, you have the summary of the course, and you have the exercise, and you have the slides. Okay, so I also added a lecture for you. The lecture, you can just download it, and then you can start reading about the the RFID and the threats about privacy and civil liberties. So this, what I am expecting from you is to just write a summary of 1-pager summary about this lecture. Okay, so it will be very helpful for you to know about some important topics related to New Brunswick. Sorry, to RFID. Okay, so the quiz for day 2 is a set of questions, and you have to choose one correct answer for 20 questions. What I will do, I will make sure that the quiz will be similar to the test you can have if you expect to do the exam for certification, RFID certification. So the questions will be quite similar to this test. So if you answer correctly to these questions, you can be sure that you can pass the test of certification, official certification. So you will have 3 quizzes, and then no document in the platform, in the library. Okay, sorry, I have a question, and I don't know if you see there is documents here. I don't know if you are seeing this, but if you go to okay, so let me I will upload them in the e-learning platform. Okay, but here you can download them from library. but maybe they are not accessible from library. I will upload them in the e-learning platform. Okay, okay. So let me do this immediately. So particularly the slides, it's very important. Documents. So I think that two documents are already available. Then I will upload the main file. Okay. So just tell me if you have now access to the documents. No, it's okay. Okay, Lisa. Okay, good. So now you can progress. So you have these mandatory duties to do. So the quiz will be done in the beginning of the session. So it will take 20 minutes. And it's not necessary to, it just require that you read your previous module, and then you will be able to answer to the question. So the right thing to do is to answer without seeing any documents. So just to have in mind the previous course. Okay. So this is why we will have quiz one the day two, because today. Okay, Nitsa. Yes, I did your I put the documents in the platform. Okay, so you have 3 lectures and 3 quizzes, and we will progress with that. You feel free to contact me by email in order to ask questions or to have any other request related to the course. So my email I will send. I don't know if my email is already available anywhere. I don't know. So I can give it to you right now. So here is my email address. Okay. Okay. Any question about the summary of the course or any comment? So for the final test, you can just have the information from Professor Naitali. Okay, let's start. RFID technology. RFID stands for radio frequency identification. Okay, radio frequency identification is not a new technology. It's all technology, 50 years, Second World War, but used in radar and communication. But now with high scale, very high scale of integration and integrated circuit. So nowadays we can have very small devices that deal with RFID. This is why the RFID technology is today technology that is becoming more and more popular and widely used in many industries and applications. So we will see for this first module the basics and the main characteristics of this technology. The outline is as follows. After a brief background, we will speak about automatic identification and data capture technologies to which the RFID belong, and then the comparison between RFID and barcodes, because barcodes it's also a very popular technology for identification and tracking. The relevance of using RFID will be the topic of this section, and then the evolution and expectations of industry and what these industries are waiting for from RFID, and then the components of RFID network. We will speak about tags, the readers, the antennas, the printer and applicators, and then some physics. It's very important, this section, because it will allow it will allow you to understand the standards and the regulations. So without physics, we cannot understand the constraints and the regulations and related to RFID. So, and we will conclude and then we will do some exercises on the physics. Okay with the outline? Okay. Okay. Now let's see the basic network, of RFID technology. So the network is basically composed of tags, and the tags are applied to the items or objects or persons, or so these tags contain the information about the objects you are tagged. Okay, and then this information is exchanged through the air and thanks to antennas. So you have antenna here. The antenna is connected to a reader, and the antenna, you have also the antenna of the tag in copper, and you can see the antenna here. And then you can exchange the data between the tags and the reader. So the reader will initiate the communication, send a request through its antenna to the tag, and then you have a response from the tags, and then you collect the information, send it back to the reader, and the reader is connected to a computer and a database management system. So here you have no obstacles, you have only the air, so it's possible to communicate this information without having any requirements regarding the directivity or something like that. So you can just put the antenna here and to interrogate and to request information from the tags. So these tags are very small. We can see later the characteristics of these tags. And this is the basic flow of information from the tag to the host application. Then you can imagine that you can do many applications with this system. So the radio frequency identification is a system that involves electronic tags containing identification numbers, unique identification numbers. So it's very important, unique. This is why you can do it, you can put these tags in your passports, for example, and now you have almost 96 countries that use biometric passports using the RFID technology with RFID tags inside the passport. So, but this is of this tag. So we can also have other type of data into the memory of the tag. So in applications and other sophisticated applications, you can imagine that you can have data into the memory, and under the condition to have enough memory to store this data. So in our lab here in Moncton University, with my students, we have many applications where we are using not only the identification number, but also additional data that we can use for many type of applications that we can to do a smart system for tracking items or other things. Okay, so the RFID is composed of the following components: the electronic tag containing an identification number and other encoded data into the integrated circuit. The tag is also called a transponder. It's very important to know all the names of the components, because if you intend to do the exam, the certification exam, you certainly will have a question about transponders, and transponders are the second name of tags. So you have to know all the names related to the components. So the tag is also called transponder. So it's the other name. The reader communicates with the tag through the antenna of the reader. This is a cable, cable here, to get information exactly like Wi-Fi network, but the frequency and the standard and the regulations are different. So it's not 801 standard .11 or so this is another regulation. So the reader manage this communication, and then it collects the information from the tags, and then it sends this information to the computer to manage this into a database or application or something similar to that. The reader has two other names. We can call it interrogator. Interrogator, why? Because the reader asks tags to give him information. So he will ask the tags. So the reader send requests. So this is why the second name of reader, RFID reader, is interrogator. And the third name, in contrast of transponder, is transceiver. Transceiver. So if I ask you what are the names of reader, RFID reader, you have to tell me that there is the second name is interrogator and third name is transceiver. Okay. So you have antenna here. The antenna is a device that is used to send and receive signals from tag and readers. And you know that antennas are widely used in many devices, electronic devices, telecommunication devices. And without antennas, we cannot communicate because the antennas will broadcast the electromagnetic wave. So depending on their shape and their gain and their power, the power sent from the antenna, so you can have the read range and the transmission range, and we will see later the characteristics of the antenna. Very important device. So the tag also has an antenna. The antenna is embedded into the tag. So what you are seeing here, the lines in copper material, is the antenna. Okay, so the integrated circuit, let me zoom it to you. So here you have the integrated circuit where you have the memory, but here you have all this, and the most part of the device is the antenna in copper. Copper is the cuivre en français, cuivre, copper. And then you have the reader antenna. So you have to perform the communication, you should have two antennas. So you have the antenna of the tag and the antenna of the reader. And then you can communicate. Okay. I don't know if the Zoom is working. Huh? Is working the Zoom? When I zoom something. Okay, good. So now let's progress. So, and then of course the intelligence is managed by the computer. Computer, you have programs, you have database, you have many things. So to process the data and receive from the reader, and there is thousands of applications, and you can imagine what you can do with this network. Okay, so the RFID is a combination of radio broadcast and digital signal processing, because we process the signal, designed to track the presence and or the movements of items. So the items could be persons, objects, animals, and so on. Okay, we talk about tagged person or tagged items. Okay, so the RFID belongs to the biggest family, the family of AIDC technologies. AIDC technologies, you have to remember this, AIDC. This is the family of automatic identification and data capture technology. This AIDC are methods and technologies that automatically identify, track objects, collect data about these objects, and digitally process this data. So if you see the figure here, so you have smart cards that are using for banking, for example, or financial operations. You have the barcodes used by the malls to give you the bill of your buying goods. You have the optical character recognition used in scanner. This belongs to, because this is the data capture. You have RFID and you have human biometrics like fingerprints and vocal identification and so on. So RFID belongs to this family. So these technologies make easy the human intervention because they help to automate the process. So they allow for a better process management. They also allow for real-time information flow and are dealing with serialization, which is a concept based on a unique identifier. Even it is optical character, it is unique because we have to define the results of related to a document, for example, when we are dealing with OCR. Okay. So what you have to remember is that RFID belongs to AIDC technologies, and AIDC stands for automatic identification and data capture. You know the barcodes, they are very close to the RFID technology, and this is why we will compare the barcodes and RFID. So you know the barcodes are now very popular. So you have to read the barcodes thanks to a device using infrared or something using light. So when we are dealing with barcodes, it is mandatory to have a line of sight. Line of sight, what is a line of sight? It's very important. It is a directivity. So you have to point the device, the reading device, in front of the barcode. If you do not respect this condition, you cannot read. So this is the line of sight, la ligne de vue, means that you have to have the barcode in front of your reading device. And you know, when you go to the mall to buy something, to buy goods, so the cashier will pass the items in front of the reading device. And then you know that the cashier will perform only one item reading. One item and one item. One item after one item, one object after one object. So you cannot perform a global reading, which the RFID permits. Okay, so this is the first the characteristic of the barcodes. And you know that because this is a 1D image for the barcode, this is a limited memory. You have the codes here, and this is the sort of memory you can have. And you can have manage limited information about the country, about the serial number of the product, and so on. So this is a limited information. What is the advantage of barcode? The advantages of the barcode technology is the low cost, widely used, well-established standard, very known. So and high storage capacity for 2D. So this is also barcode technology. And could you please tell me where you can see this type of 2D barcodes? Yes, where we can see this? Everywhere, I know, but just yeah, just yes, it's in yes, but also on flight tickets and so on. So because it's very, you can store many other information. Yeah, the memory. Why I limited memory? This is the memory. The memory is this code, these numbers. Okay, so with these lines, you can you store information. It's a code. Okay, so with the light, you can the width of these lines and their you can have combination that you can give many combinations to have diversity of information, but you still be limited by the number of because imagine you have a billion and billion of objects in the world. So okay, so this is 2D, so you can store information 2D space, and you have also the color, the shape that give you more than the 1D possibilities. Okay, so if you compare this with RFID, RFID does not require line of sight. This is very important, and this is the advantage, a very huge advantage, because you can have only the objects in the space, and then you know because you have the request from the reader that the object is in this space, okay, without directing the reading device to the tag. So the RFID also allows for multiple readings. So you can imagine your cashier in the mall. You can okay. Okay. So imagine that you can have the bill in real time immediately. Your shopping cart, you just pass through the antennas, and then you have in 1 second, or maybe less than 1 second, you have all your items listed, and you can have the bill that you have to pay. So because you can perform multiple readings, okay? So you can have inside the chip up to 128 kilobyte of memory. So to store data. You have, of course, a unique identifier, and writing capacity is bigger than the barcodes. Okay, so this yields to secure the data. So you have more security because the data are inside the integrated circuit. So it can operate in adverse conditions, like in darkness. So you're and in dusty environments, and the RFID can operate in this very hard environment condition. And of course, you can combine the RFID with sensors, and then if you have sensor, you can have, besides, in addition to the unique identifier, you can have also some other information. For example, if you read information about an object, you can also have the temperature of this. You can have the other information about this. So it's very helpful when, for example, you are dealing with some very important objects, like human parts, for example. Yes, up to yes, 100. It's latest technology. So the normal size, it's 8 kilobytes. 8 kilobyte, but now we have companies that are selling 64 and until 120 storage capacity, which is very big. Yes, Haytham, I mean, yes, we will. This will be a long session about this, about the distance between which is the distance, the best distance, how to perform the reading, the good readings. Will be the subject of our course. So just follow, and then you will understand exactly how it works, and the conditions, the restrictions, and the best conditions of working. Also, combination with sensors, I will give you an image. So just maybe 3 or 4 slides later. It's semi-passive tags. I will explain to you how we can combine with sensors. So you have tags and you have devices connected to the tags that, for example, sense for temperature or something, or humidity or something else. So I will show you. Sensors will be with the semi-passive tags, and I will give you. I will show you an image about that. Okay, so good questions. So why we are using RFID? We use RFID for security and authentication. So access control, for example, with so here we have passports. So you can control the access to a place. So without having the near reading, or it will be distance reading, and very comfortable for the users, and you can manage a big crowd. So here in Canada, a company managing music concert uh, worked with us in order to manage the access control to of the crowd of people. So it's very easy because you cannot you can just have a distance control, and then you can manage a big number of persons entering the space where the music concert uh,
So stores between 128 byte to 8 kilobyte, which is the norm. But Fujitsu and other companies make dramatic progress, and then we can have tags that have 64 kilobyte of memory, which is the largest of the market. So sorry, Hassan, this is 128 byte, okay, not kilobyte. The maximum we have today in the technology is 64 kilobyte inside the tag, okay, Fujitsu tag. So just okay, so just recalling the fact that the RFID does not require a line of sight or contact. It provides security. It operates in adverse environments, reads multiple tags at the same time, and offers the read and write functionality. So in contrast of barcodes you cannot write, but with RFID, you can use this memory to read and write what you want, information inside the tag. So you can read it after that, and you manage it with a computer. So this is very important to remember, okay? So the main advantages of RFID. Remember the network, remember the components, and remember the main advantages. So to summarize, you have a tag, the antenna of the tag, exchange of information with the reader exchange with host system, the reader take data and manage information. So you have the request, and this is the very summarized network. Okay. Why you need to plan for RFID? Is this all technology, promising technology, the potential of the RFID? If you see here, ID TechX, which is a important consultant group about technologies and IT, and the market research about RFID finds that in 2018 that the total RFID market will be almost 20 billion, 20 milliards de dollars. So 19 billion. Okay, so you have the progress here, you have the increase, dramatic increase. So even you have a very, very little increase in other IT technology. For RFID, there is dramatic increase. So you can see the real market size in the previous years, and it's still growing. Okay, this is a growing technology. So here you have the tags, the market size of the tags. You will see what we will see together what is the meaning of passive tags, RFID tags, and other. So the market of the tags will reach 4 billion. The readers, so will reach yes, 10 billion. And services, so you have RFID services, software, networking, and so on. Also, it's an active market. And you have the active RFID. Active RFID is another type of RFID technology. We will define it later, which means that this active RFID means that we are using sophisticated communication systems to broadcast information to a long distance. Okay, to long distance. So, and this RFID technology is also used to for localization. So you know that GPS is used for positioning into a grid space, but RFID can used indoor, for example, inside a building. So inside the building, you cannot use GPS, but inside building, you can use RTLS system to find the position of a person of object. So it's very useful in hospitals, for example, to see where are the patients and where are some very important objects, for example. So we can use the RTLS system, real-time localization system. So it's this type of market is very important and increasing too. Okay, so this is to show you that the market of RFID is still growing. It's a very important market, and the size of this market is increasing. So as I said before, 96 different countries, including the US, are now embedding RFID into passports. So these applications, for example, to manage the gun, which is a very important problem in US. So to manage the guns and the weapons, where there is an RFID design to improve the gun control, and the idea is to put an RFID and to read the information of the gun and to match the information of the owner of the gun, the legal owner, and the gun. And the shooting is not allowed except if the identification is done and the legal owner and the gun the information is matched together. Okay, so this is an application. So the US Food and Drugs Administration also approved the RFID tags inside the human body. So this is you have tag here and you have the information stored here, so you can manage many things. So you can also put a drug here and you can let the drug diffuse inside the body for diabetes, for example, or something like that. So there is many other applications of RFID, and you can just read the information outside, and then you can see many useful information. So this is allowed now by the UFD. Okay. So another type of application, RFID-based biometric identification technology in education, student and teacher attendance. So we can manage the absence and the presence of the teachers and the students. And Walmart, which is a very huge mall, like in France, Carrefour, but it is a worldwide company, and it mandates all of its 15,000 suppliers to attach RFID tags to their pallets, because they can manage the inventory and they can control the inventory, and then they can send in real time the goods that the retailer needs. Okay, so there is some examples where you need to plan for RFID. Just recalling the network, you have the reader, the antenna, communicating with the tag, and then the reader is connected to a database server, and even on the web you can access to the information related to the tag. Okay, so now we will go in depth for the tags and so on. Do you have any question at this time? Now we'll go to another section, detailed section about the tags and so on. Okay, good. So we have many types of tags, and we have mostly three types of tags. We have passive tags, semi-passive tags, and active tags. Okay, so you have passive tags, active tags, and semi-passive tags. Okay, three types. So you have to remember this. Passive tags. As the name is telling to us that passive is passive, so you do not have energy. So this type of tags uses the energy of electromagnetic signal it receives from the reader's antenna after a request. The chip is then powered on, so it can send its response through its own antenna. So you have passive tags here, you have the chip here, you have the antenna. So the reader will send through its antenna electromagnetic wave. The wave enters the antenna of the tags. Then this wave will give energy. So you haven't battery here or something like that. You have only the electromagnetic wave coming to give energy to the tag, so through the antenna of the tag. So this is why we called it passive. Passive because the tag does not have battery or energy source. Okay. So use the energy of electromagnetic signal it receives from the reader's antenna, and after the reader is requesting the information from the tag. So the response after that, when you have this, the tag will send the information which is saved into its memory. So we can use this communication to save information into the memory, or to collect information, or to retrieve information from the memory. So it's bidirectional. So store information about an item, process the request coming from the reader, and prepare and send the response. And the process of communication, so you can read and write, and you can use the energy of the reader's antenna. So there is different shapes of passive tags. So when you have these strange shapes, this reflects the frequency of working, and maybe the dimension where the tag is implemented, and so on. So there is many type of passive tags. So, but basically, you can have the technology is here. The composition of tags. So you have what you have here, the chip. Okay, the integrated circuit, and you have the antenna here, the antenna, which is here, and you have a plastic. It's a plastic here, and you have adhesive here and liner here. So this is not active devices. So this is so when you have electromagnetic wave, they go to the antenna, and the antenna power on the chip, and then you can use a protocol, reading protocol, like Wi-Fi, to save or collect information from the memory. Okay, so the main thing to remember is that the passive tags uses the energy of the electromagnetic signal it receives from the readers. It does not have its own source of energy, so no battery. In contrast of active tags, the active tags, so you have battery here. This is the active technology. Remember the active RFID technology. So the active tag uses an internal battery to run the microchip circuitry and to broadcast the signal to a reader. So you have the possibility to broadcast signal. Even if you have a reader, you can send signal. You can send signal from the tag. The onboard power source enables the tag to broadcast signal out at read range by other constantly, so you can send continuously the signal, and this is what we are calling beaconing, and this is why this type of active tags are called beacons. So beacons, and this type of tags are used mainly, for example, when you are a car resellers, for example, vendeur de voiture, expensive cars, for example, Rolls-Royce or so on. So you have this type of beacon. So you can see, even if you haven't reader, just you can see, you know that your beacons are emitting a signal continuously. So you are sure about the position of your car. You are sure that your car is in your parking, and you are sure that the position is and even if you have if your car is stolen, so you can follow the position of this beacon. This is why we have beacon, and this requires a battery, internal battery, to broadcast the signal. You have also another type of active tags. You have battery, but you initiate the reading or the communication only if the reader requests. The reader requests the information, so you have the broadcasting of information. The advantage to have active transponders or active tag is that the active tags can broadcast very far from the original distance. So the distance of broadcasting can reach 1 kilometer. Okay, so this is the difference, because you have an internal source of energy, so you can broadcast with a powerful energy, and then you can reach a great distance. You can reach great distance for to send the information. So other difference compared with passive tags is that active tags can carry a lot more memory than passive tags. Okay, so there is difference between passive tags and active tags. The applications differ. The third type of tags are the semi-passive tags. They are not passive, they are not active, but we call them semi-passive tags. And then the question of Hassan, I think, who told me about sensors. So this type of semi-passive tags are mainly working as passive tags, but they are additional circuitry. The additional circuitry is used for sensors. So we have battery here into semi-passive tags, but only they use a battery to power the circuitry because there is many type of circuitry, but they communicate by using the power from the antennas radio waves received from the reader, like passive tag. Okay, but the batteries are used to power the sensors. These tags have greater communication range because they are more sophisticated than passive tags, and you can have the sensor capacities. Okay, so they are used to track and to tag perishable products, for example. Yes, yes, Hassan. Yes, time info, many time. Because if you are, for example, you in human surgery, for example, you need an organ, a human part. So you have to travel and you have to track this in order to be sure that the human part and human organ is respecting the cold chain, and that you have, so you have to manage the time, the temperature, and so on. And when traveling, the reading is done. So you have RFID to track the reading and to track the tag, and you have sensor capacity. So it's very important. Okay, so I have a question, please. I would like to know if data are encoded inside tags and what kind of system is it to device. Okay, this is the reader who will encode the data into the tag. And the type of data, we will see it later, okay? So into the memory, I will give you the architecture of the component. So into the memory, you have some reserved place where you can put data, and you have protocol. You have a protocol using the reader. So the reader is the brain of coding. So the passive tag, you have only the storage of the information. So there is a comment from the reader. So for example, read this place of memory, kill this tag, open this size of memory and give me information. If you have semi-passive tags, we know where is the time information, the temperature information, so we can. So the reader is the brain of that. You will have a program, a basic program, basic coding in the reader. We called it firmware, but you can program a layer, application layer. In the application layer, you can program your also your request. Okay, so we did that in our lab here. Okay, so remember 3 types of tags: passive, active, and semi-passive. So please read this carefully because tomorrow I will ask you about that in the quiz. So the 3 types of tags, you have the passive, the semi-passive, active. So the tags, the passive, the power is only from the reader thanks to its antenna. The semi-passive has its own battery, like the active. The communication is done from the reader, and the electromagnetic magnetic wave sent from the reader for passive and semi-passive. So the active, the communication, the broadcast information is done thanks to the battery. So the passive tags does not have computing. They have memory, but not processor, only memory. Semi-passive, you have processor and memory. Active, you have also processor and memory. So the passive tags, for the semi-passive tags and active tags, you can have the read-only possibility in the memory, the read-only. You can manage to have only a read-only memory, but you can have write-only, write once and read memory, read multiple. What is the meaning of write once? So read only, it means that the manufacturer of the tag will give you a unique identifier, a code, unique code, like a serial code of products, or maybe in for the cars you have a serial number of a car. This is worldwide and unique code. So the manufacturer will give you a unique code, and you have, this is why you have only read-only possibility, okay, to manage with this code. Only reading, you cannot write inside the passive tag. This is a type of passive. You have three possibilities. So you can have this type of tags that are very cheap, and because you are, for example, selling maybe some for nutrition, I don't know, maybe it could be something to eat, or so you do not need to have a sophisticated reading and writing into the memory, because your needs are only to count these items, these products, and you need only to read the unique number, identification number. So this is very cheap tags, and you have the possibility to read only this unique number from the memory, and you have this capability for the three type of tags. But you have also the possibility to write once. It means one time when you buy this tags, you can write only one time. You can write the code, or your personal code, or your company code, or something like that, but only once, and then you can read multiple time and read this code. So the manufacturer gives you the possibility to write your own information, but only one time. After that, you can read this information many times you want by the reader. But you have also the full capacity, which is the reading and writing many times into the memory. You can erase the information you have into the memory, and then you put a new information, and then you erase, then you put a new information, and you read this information many times you want. Okay, so you have now, with the new technologies, we have these three possibilities for the three type of tags. Sure that the tags, the passive tags, are very inexpensive, 5 cents or maybe less than 5 cents if you have 1,000, and you can print them by printer. I will see later how we can print these passive tags. The semi-passive are expensive, so more expensive than the passive tags, because of the fact that you have many features added to the basic configuration, and the active are more expensive. So this is a summary about the tag characteristics. Very important slide. Very important. And all the questions for certification also on are asking about the class, the classes of the tags. So we have six classes for the RFID tags. So remember, we are speaking about the tags. Okay, so you have three type of tags: passive, semi-passive, and active. And you have six classes. Class 0 to class 5. Class 0 are read-only tags. Okay, you cannot exchange information on, you cannot write information, and you can only read the what we call EPC number. The EPC number, this is the electronic product code. It's a unique code that the manufacturer, the producer of RFID tags, give to the tag. So you have a unique electronic product code, EPC, EPC code, and EPC is unique when we are dealing with class 0. So EPC is like a serial number of cars. You know that for cars we have a unique number, identification number. So you have EPC for the six classes, EPC. And the class 0 will allow you only to read this EPC number. Okay, and EPC number, as it is unique, you can manage this because you have, yes, it's like a MAC address for computers and networking. Yes, exactly. Yeah. So the class 1 is the passive RFID. Passive RFID, but the passive RFID where we can write one time and read many times. Okay, so there is gradually we can increase the capacity. So here you are allowed only to read. Here for class 1 to write one time because you have the manufacturer gives you the possibility to personalize your RFID tag, your passive RFID tag in class 1. Okay, and but after you are writing this information, you can one time you can do reading after that, and you are only in read-only mode, read-only configuration, because you are not allowed to write second time or third time. You cannot you are not allowed to erase the information and to write a new information for class 1. Okay, so class 1 is this. Class 2, so let me tell you that class 2 is the very popular because they are inexpensive. They allow you to write multiple and to read multiple. So you can erase information. You can, not the EPC code. The EPC is unique, but information related to this object, to the object you are tagging, you can change it. You can remove the information into the memory, and you can put a new information and you can read. So you have facilities. You have the possibility to this is class 2. Class 2 is very popular in passive tags, so the passive technology. And this is related to what we call the generation 2. EPC Global Generation 2 is a tag with electronic product code. Generation 2 designed to work globally and enjoys the support of major manufacturers. This is why Generation 2, this means that you have EPC code like MAC address, and you can do write multiple and read multiple, and you can travel with your tags globally, worldwide, and you can have unique identifier, and so you can have applications with your suppliers or your providers worldwide. So any place in the world you can use it because you have unique identification number, and then you can use reading and writing many times. This is passive tags, class 2. Actually, and currently, this is the most used class. Class 3 is related to semi-passive. So you have semi-passive tags, you have write multiple and read multiple. This is class 3. Class 3, the semi-passive belongs to class 3. Class 4, the active, beacon and not beacon. Okay, and class 5, smart tags. So these tags are some reader capabilities. So you can have communication between tags. So very sophisticated tags that you can have a request from tag to tag, and you have a communication without needing to the reader. So this is expensive and high level communication tag to tag. So this is class 5. Okay, so you have 6 classes, 0, 1, 2, 3, 4, 5, and remember the features for each of each class. Okay, very important. So tomorrow you will have a question about that. So just to tell you that the quiz are not counted for your final marks, or just for you. It's an auto learning or auto evaluation for you. So I can see tomorrow if you understood or if you are ready for this concepts to pass the certification exam. It's up to you if you want to do the exam. So prepare it in such that you have all the required background. So, and this is very important. So maybe we can take a 10 minutes break. Yes, 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 yes. Yes, Hannah, yes, the smart tag is also write multiple and read multiple, of course. So are you agree with the 10 minutes break? Is it okay for with you? Okay, just 10 minutes. I will take a coffee and I will stop the recording. Okay, so let's go. We have many, many slides to go. Yes, so we have to. So this is the APC code. I don't know if everyone is back. Please confirm that it's okay. 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 So the electronic product code is 96 bits code. So this is the main information which is inserted into the chip of the RFID tag. All RFID tags have EPC, and EPC we are talking about EPC global. Why global? Because this code is unique and is used globally, worldwide. So this is important for your business, for your communication, for if you have this code inserted in your passport. So you want to be sure that this code is unique. So you cannot have a passport with codes, multiple codes, same codes. So this is why this is important to have unique code, and this is global EPC code. All manufacturers respect this EPC code, and this is 96 bits. So for this 96 bits, you have 8 bits for the header. Header it gives the possibility to check if the code is correct. If so, when you have communication, this header allows for synchronization and something like that. So this is 8 bits for the header. So it identifies the type, the structure, the version of EPC. The EPC manager code is 28 bits. This is related to the company. Your company, for example, you have a specific code. So maybe it could be the government of France, for example, for the passport. So you have 28 bits for the coding company, EPC manager. Then you have have the product. For example, this is the country, the company, and you have many products. This is for the product class. For example, you have you have you have passports, but you also have cars. You have other type of product. So this is the big class of product. Okay, so it's 24 bits for the object class, not class RFID class 0, 1, or no. This is the object category, the object group, the object or the product family, or so you can have many type of products. So the company, the products, and then inside this product, you have a serial number, the item. So this is 36 bits. Okay, serial number. So the object class is identify the products or the type of product, and then the serial number. This is 36 bits, and it identifies the product, the item of the product. So it could be, let's have this example. So you have header for the type of EPC. Then you have France as the company, government of France, for example. This is category maybe passports. So there is other things, maybe cars or guns, but here you have object class passports, and then you have the serial number of your passport, for example. Okay, so this is the EPC code. Very important to know, and very important to know the size of each size of this memory, each category of information we are saving into the RFID type. Any question? Very important EPC. EPC, electronic product code. Okay. So in all RFID technology, EPC is mandatory, and PC is this code. After that, in the memory, you can save information you want. But we will see later how the memory is structured, how it is organized in such a way that you will allow to you to save the other information. But this information is done with the manufacturer, and they can and if you you are buying tax, you can have this information saved into your tax. The readers. So you have also many type of readers. All these readers are in our lab here in University of Moncton. So you have fixed readers, fixed handle, fixed, and mobile. So you the RFID reader, you have a reader which is also called transceiver. Remember the name, also called interrogator. The cable between the reader and the antenna is up to 80 meters. If you go beyond 80 meters, you will have a strong attenuation of the signal. So this is why usually we have between 30 and 85 meters, okay, for the cable. Of course, you can have less than 30 meters. You can have 5 or 6. Okay. So you can have fixed, mobile, or handle, fixed, and mobile. Mobile because you can travel with it on forklift or something like that. When you have managing your warehouse, for example, you can have a mobile reader. So when an RFID transponder, which is a tag, transponder is the other name of the tag, enters the antenna field, antenna radio field of the reader, because the reader is connected to the antenna. And when here the antenna is here for the handle. So this is the reader, okay, and here you have the antenna of the reader, because you can take it with your hand. So when you are performing reading, so you have space here, which we are calling it the radio field, electromagnetic radio field. Okay, here. So let's draw a tag here. And the antenna send the request through electromagnetic wave. When the tag enters this field, this space, so there is communication. And you can read information about this. So there is not mandatory to have a line of sight. Line of sight, it means that this is direct. You can have the tag here. Okay. You can have tag here. And you can read because the waves are everywhere. Of course, to have read range, and we can see later what is the reader range. Okay. Okay. So when the tag enters the electromagnetic field, it becomes active, and then we send back the information to the antenna, and then we can read the information into the memory. So the reader here, the reader is here, can also send many other commands like killing a tag in order to render it unusable. Okay. So this is a kind of application. Antennas. So an antenna is any structure or device used to receive or radiate electromagnetic waves. They come in various type and configurations. So this is also antennas we have in our lab.